an as, I got an as, check, a minus 1 raised to n divided by pi a square plus n square, a minus 1 raised to n divided by pi a square plus n square, I can write 2 here, and sine hyperbolic a pi. In the similar way we can find bn. So I start with bn formula 1 upon pi minus pi to pi f of x into sin nx dx. So we can put f of x here now. That comes to be 1 upon pi minus pi to pi f of x is e raised to ax into sin nx dx, which comes 1 upon pi formula is e raised to ax divided by a square plus n square a sin nx minus b cos nx. So we can keep upper limit as pi and lower limit as minus pi. Let's substitute upper limit and lower limit, which comes to be, when I substitute upper limit, that comes e raised to a pi divided by a square plus n square, sin n pi becomes 0, cos n pi becomes minus 1 raised to n, which comes to be minus b. Sorry, I need to substitute b as nothing but n. So that comes to be minus n, and cos n pi is minus 1 raised to n. So that's my upper limit, that is upper limit when I substituted, minus when you substitute lower limit, that comes to be e raised to minus a pi divided by a square plus n square, and then when I substitute again sin n pi, that becomes as 0, and here it becomes minus n. When you substitute cos of minus n pi, that again gives minus 1 raised to n. So which I can write as, finally taking common as, minus n minus 1 raised to n, I am taking it common, divided by pi into a square plus n square, I am taking it common. So remaining will be e raised to a pi minus e raised to minus a pi. I can write my bn as, you can see here, I got minus n minus 1 raised to n, minus n minus 1 raised to n divided by pi into a square plus n square, e raised to a pi minus e raised to minus a pi, if we divide it by 2, you get as 2 sine hyperbolic. We can write now as 2 sine hyperbolic a pi. So finally I got a0, an and bn, which I can keep in series f of x, that's equal to, my a0 value is 1 upon pi a sine hyperbolic a pi. I can write this as sine hyperbolic a pi divided by a pi, and then this was a0. I got an as 2a minus 1 raised to n, plus I have a summation n equal to 1 to infinity, and then I can substitute an, that is 2a minus 1 raised to n sine hyperbolic a pi sine hyperbolic a pi whole divided by pi a square plus n square, pi into a square plus n square. So this comes, multiplies with cos nx, plus my bn comes to be minus of 2a n. A is not there, there is only minus of 2 n minus 1 raised to n and sine hyperbolic a pi, the whole divides with pi into a square plus n square into sine nx. So this is my final series which I got.